Okie dokie, so today I'm going to be talking to you about acidulants, pH control, and leavening agents. And I'm going to start with the acids. They are organic and inorganic and occur naturally. And the reasons that we use these are for flavor, buffering, pH control, to prevent microbial growth, as well as chelating agents, and to stabilize color. And let's start off with the flavor adjustments. A flavor adjustment, it's just to enhance or modify the flavor of beverages or hard candy or things of that sort. And it depends on the intensity of the acid, depends on the taste. I'm sorry, the intensity of acid. Yeah, I said it right. Sorry. And so it's the total concentration of hydrogen atoms and not the actual pH. So while most times for different things we look at the pH, for the intensity of acid, we actually look at the concentration of hydrogen atoms. And this is used to add tartness and balance out the sweet taste, because most of the time these are used in things such as marmalades, gels, pectin gels, jams, jellies, hard candy, and also soft drinks. And an example of this would be tartane acid used for flavoring grape products, whether it's grape hard candy to grape drinks. And also phosphoric acid is used for cola flavored products. So those are just two examples. There are many more, but I just wanted to share a couple with you. And acids can also be used as chemical preservatives, and the purpose of that is to stop or slow microbial growth. And this is true in fermented products such as sauerkraut or yogurt, where the acid is used to ferment the product until a certain point for the desired taste. And they also enhance the effectiveness of pasteurization and sterilization processes. And acids that are used only as preservatives are acids such as acetic acid, benzoic acid, sorbic acid, and propionic acid. And then acids can also be used for coagulation. An example of this would be tofu directly, and also directly acidified cheeses. And then for chelating agents with citric and phosphoric acid, they bind metal ions. They kind of act as antioxidants when they bind metal ions that promote oxidative reactions such as enzymatic browning in vegetables and fruits, and rancidity in food products that contain fats like meats and things of that sort. Now, pH control. pH control is important because it is essential in the gelling of fruits and jams. Like high methylpectin needs a pH of 2.5 to 3.5. And also the release of carbon dioxide in leavening agents, because if the pH is too high or too low, then the leavening agent won't work and it'll change the structure of your baking product, which is not good because no one wants to buy a flat cake. It just doesn't work out that well. Also, the taste and the tartness of drinks. So, some of the flavors that you get in drinks, like you have the grape soda or orange soda, things of that sort. And also the efficiency of some preservatives, because preservatives need a certain pH to be effective. So if the pH is too high or too low, then it could cause the preservative to not be effective anymore, and it could cause rancidity in your product, as well as some off flavoring, some off flavors, and just different things that can go on when you do have problems with your preservatives. Also, buffering is extremely important. It prevents the change of a color or a flavor, and also prevents, an example of that would be prevention of Maillard reactions, such as enzymatic browning, because while there may be, while some reactions may be desired in some products, if you don't want that reaction, then once that reaction happens, it makes the product less desirable, and it's less likely that your consumers are going to like it or buy it. And it also ensures that acetic and lactic acid maintain their fermentation, because without that, they don't do what they're supposed to do in products. And this causes problems with, once again, like off flavoring, excuse me, with off flavoring and things of that sort. And the widest range for a buffer, an acetic buffer, would be citric acid, with a range of 2.5 to, 2.5 to 6.5. So that's a pretty great range. So citric acid is used in quite a few things. And then here are just some examples of some acids and what they do or how they're used. Acetic acid is a flavor modifier and preservative. It's used in ketchup, mayonnaise, and pickles. And then citric acid can improve aroma, and it's used in the process of candy making, in fruit juice, in jelly, in some ice creams, in vegetable canning, also in processed cheese, and also in buttermilk. And lactic acid improves the flavor of drinks, like soft drinks, also pickled vegetables, and prevents discoloration in some products. And fumic acid increases the shelf life of some dehydrated products, such as like Country Time lemonade that you would get in the can, that all you have to do is add water to it, things of that sort. And then tartaric acid helps with the acidification of wine and fruit drinks, and also sour candies, and gives it that little tart flavor. And then adipic acid helps in gelling and marmalades and jellies, in improving the texture of cheese. I'm sorry. Okay, now we've come to leavening agents, which is personally one of my favorites. And so just to review, I told you a little bit about acids and how they, acidulants, and how they play a role in food, and the different things that they do, from maintaining the pH to the flavor of the food, to also acting as a buffering solution, which is where pH control comes into play. Now I'm going to tell you a little bit about leavening agents. And leavening agents are compounds that react to release carbon dioxide in appropriate moisture and temperature. This is normally used in baking products, like doughs and doughs that are used to make cakes, breads, things of that sort. And they're added in 1 to 2% concentrations. They're already found in self-rising flour and baking mix, like you would get a cake mix, and baking powder, and refrigerated dough products, such as those things are pizza crust that comes in the can, or biscuits that come in the can, like the flaky ones and stuff like that. And examples of leavening agents are ammonium salts, baking powder, baking soda, and cream of tartar, carbon dioxide from carbonate or bicarbonate salts. So it is important to have the carbon dioxide in order to so the product will rise. And ammonium salts decompose when the product is baking, so they do not require. They rise on their own. I mean, react on their own and do not require acid. Is something that would be found in like cream of tartar. Leavening agents can be slow or fast acting, and depending upon what you're looking for, that's what you would choose for your leavening agent. And also, an interesting thing about leavening agents is they can alter the taste if there's an example of this would be baking soda. If there's too much baking soda, you'll have a soapy taste. But if there's too much acid and not enough baking soda, then you'll have a tartness or bitterness. And so these are just a few things about acidulants, pH control, and leavening agents. I hope you enjoyed this video and that you learned something. Thank you so much for watching.